Okay, so far A and B, they haven't changed. 7.5 horsepower, 120 volts, they're given. Go to D2. D2, select 58 amps. That's their nominal current. Time delay fuse, you go to D16, 58, you go all the way across. You're going to use a time delay fuse of 80 amps. Now your disconnect switch. It gets a bit trickier here with the disconnect switch. If you go to the very last page or second last page of this handout.
H313.
This guy here, page number, what page is it? Page number 7. This is for your disconnect switch. So what you have to do, remember this, write it down on a piece of paper. You're not going to remember this when school starts. Heavy duty. For a motor, it's always heavy duty. Okay? A motor, when you're activating it or when you're deactivating it, there's a lot of current, and it could cause arcing on a cheaper switch. Okay? So it has to be a bit more robust, heavy duty, especially if you're cutting the current.
Is it heavy duty fusible or non-fusible?
It's going to be fused. Okay? We're choosing a fuse, right? B was fuse. So here, number of poles. Now this one here is a bit tricky. Okay? Well, we're still doing DC. Number of poles. What are we cutting? Let's just say we're going to cut just the positive, okay? Not positive and negative. We'll leave positive. We'll leave the 2 poles for a 240 single phase motor, which we'll talk about tomorrow. And the negative will need a neutral lug, okay? A neutral lug. I'm going to show you a picture of this eventually. So we have a positive. The positive is just one wire, right? If I have a positive and I have a negative, that needs to go to the motor. You go into a disconnect switch. Now, what does a disconnect switch look like? It's got a lug, okay? And it's got a disconnect. It's got another lug, or actually this one here would be fuses, but that's one disconnect switch. And then you have a neutral lug. What does a neutral lug mean? It means that you have to buy a neutral and you actually have to install it inside the disconnect switch. Okay, it's sold separately. So for DC, we're cutting off the positive, and the neutral, the return is going to have to go to the neutral lug, okay, which is isolated to the ground. So in other words, for our disconnect switch, we have an H. What does that mean? It means we're going to choose H. It means that the code is going to be H for heavy duty. We're going to use one pole. Yeah. Our voltage for this one here was 120 volts, which is a 1. And now our amperage. This is the tricky part, okay? It says nominal, but there's an issue. The nominal here, if we go with nominal, we had 58 amps. Do you remember?
Yeah.
58. So 58 amps. If you go with that, it means that you can choose a number 2.
Number 2.
There's a problem. Because eventually when we're going to get to read the articles in the code book in section 28, there's a clause that says that you have to make sure that the fuse can fit inside the disconnect switch, which means that we're fusing at how many amps here? The fuse we said was
80
amps. Now, I don't know whether you remember or not what the denominations are for disconnect switches, but I'll list them up here. You can get a 30 amp disconnect switch, kind of like breakers, right? 30 amp. You can get 60 amp, which is a little bit bigger. So if you have a fuse that's bigger than 30 amps, well, it's going to fit into the 60. If you have a fuse that's greater than 60, well, then you need a 100 amp disconnect switch. If you have a fuse that's over 100, well, you're going to have to go with a 200 disconnect switch, okay? You see the pattern here? Then there's 400. They're right over here, 200, 400, 600. So if I have a fuse that's 80 amps, it's not going to fit in a 60 amp disconnect switch. So I have to purchase a 100 amp disconnect switch. So even though it seems, based on what it says here, nominal 60 amps, in reality, we have to use the 100 amp. So the next letter here is a 3.
So here we can't read the normal. We should read the fuse.
Yes, because as I said before, in section 28 of the code book, there's going to be an article where it says that the fuse holders have to be large enough to accommodate fuses.
Oh,
Okay, so nominal, yes, but the thing is, with motors, it's a bit of a special case. Okay, with heating, you don't have this issue. With lighting, you don't have this issue, right, Sardi? You're not paying attention, Sardi. This is important.
Yes.
Okay,
No,
fuse
I know.
80. 80 is for a 100 amp disconnect switch. So you have to go with the fuse. Go with the fuse. Sometimes it'll work out to the same disconnect switch, but the fuse takes priority. And so the last number or digit here, because we were said that we're going to use a neutral lug, this guy here, for the negative, we're going to have to put an N here. So H113N is what we have to purchase. Heavy duty, one pole, because it's DC, we're going to cut off only the positive. 120 volts. So this one here would be 120 volts. We need a disconnect switch that's good for 100 amps. That's a 3 and a neutral lug. So H113. Let's go back. H 1 1 3 and N. Heavy duty. This guy here is the amount of poles. So instead of going back to the bottom page, let's just write it here. This guy here was for
Voltage.
volts,
what did you?
voltage. This guy here is for amps. And then this, the N is for
Neutral.
neutral lug.
But
I'm just gonna-
we did the same process for transformers, no? The
I don't
same-
know.
Yeah.
Could be.
Sir, can you go back to the page after with the disconnect switch chart?
Where is the neutral?
Yes. The N stands for neutral lug.
I'm saying in the diagram.
What diagram? This is just a generic picture to make it look nice. That's it. This, don't take too much stock in what's here. It's just telling you basically here you have a rigid conduit or EMT, whatever, 2 wires. You have the motor starter, and then you have 2 wires with the bonding. It's just a picture. Don't worry about that. It's not relative.
How do I know there's neutral?
So like I said, with DC,
Okay.
what do we have? We have a positive and we have a negative. It's kind of like AC single phase, 120 volts. What do we have with 120 volts? You have a line and you have a neutral. Well, let's say this is your line and this is your neutral. You understand?
Yeah.
Okay. So Dante had asked me to go back. So if everyone's finished, we'll go back.
Yeah, just for 1 second, I want to take a screenshot of it.
Okay, go ahead. This is going to be a video, by the way, right? So at the end of the day, I'm going to send you the link for the videos. Got it?
Yeah.
Yeah.
Thank you.
Okay. Conductor size. Well, this is it's not any different than before. We did this before. The only thing is, instead of using table 6, we're going to use tables 8, 9, and 10 here. Okay, just like we did before with the bonding. The size of the contactor and the size of the OL, these are going to be new. Okay, so let's go with the size of the contactor. For the size of the contactor, we're going to have to use, I don't want this to get messy, but just to show you, you're going to take the nominal. You're going to bring it down here. The size of the contactor, you're going to use the nominal. What is the nominal? 58. And then you're going to go to a table, but a table that's not in the code book. It's a manufacturer's table. We're going to go back to the page we were at before with the disconnect switch. So the size of the contactor. Let's go back to page number, was it 7? Page number 7. Here, the contactor. Okay, the magnetic starter, magnetic contactor. What was the amperage? 58? Well, here what we're going to do, we have to choose a NEMA size based on the nominal. What does continuous mean again? Continuous and nominal mean the same thing. So 9 is too small, 18 amps is too small, 27 amps is too small, 45 amps is too small.
90.
You can use 90. And 90 is a NEMA 3.
NEMA,
Okay,
what meaning?
NEMA is a manufacturer specification.
Manufacturer.
Manufacturer specification. So a NEMA 3. So if we go back to the top, right here, what we're going to write down is a NEMA
NEMA.
NEMA 3. Dante, stop texting. And then for the OL, we need this guy here, the service factor.
Oh, yes.
Let me color code this. It's the first one. Let's go with black. Service factor. This guy here, the only place you're going to need it is right over here for the OL. This guy here, we're going to have to go to the code book. All right? The code book will tell us whether we should take the nominal and multiply by 1.15 or 1.25. Okay, so let's go to page 7 and write it down here so you don't forget. I'm going to go to page 7. Same, or actually it's page 8. I'm going to have to go back and change that. Page 8. This is an article in the code book. This is article 28306. You're going to have to pay attention and understand this because you have to know when you choose your OL, your overload, okay? There's a little dial on your OL and you're going to have to put it to a specific amount of amps. So that specific amount of amps is determined by doing a bit of math. So if you look here, it says that and this is taken from the code book. This is actually article 28306. For a motor with a coefficient, this coefficient is the service factor. Write it down. Coefficient is service factor, not safety factor, service factor.
Oh, service factor.
The coefficient is the service factor. So A says that for a motor with a coefficient or service factor of at least 1.15, that means 1.15 and greater. So if it's 1.15 and greater, you're going to have to multiply nominal by 1.25. Okay. Let me finish explaining the next one. It says here for a motor with a coefficient, again, coefficient is a service factor of less than 1.15. So less than 1.15. I'm just going to add something to the very top here, right? It said greater than. It's greater than or equal to. This is greater than or equal to. 115, 1.15, greater than or equal to. So if it's 1.14, what do I do? So example, if I have a service factor of 1.14, what do I do to the nominal? I take the nominal and I multiply it by 1.15. So I'm either multiplying by 1.15 or I'm multiplying by 1.25, depending on the service factor. Okay. This will make more sense once we finish some exercise and we apply it. Okay. Again, this is the reading that you're going to put on the OL. Okay. There's a couple of examples here. So for a service factor of 1, Well, is 1 less than 1.15? Yes. So you're going to multiply by 1.15. This is the nominal amps. You're going to set the dial on the OL. Set the dial on the OL. 223. Now, to add to this, sometimes OLs are already compensated for 115 or 125%, okay? But let's say it isn't, you're gonna have to do the math. The second example here, if the service factor given is 1.2, now is 1.2 above or below 1.15? Mohammed, is 1.2 bigger or smaller than 1.15?
It's bigger.
Bigger. So if it's bigger than 1.15, I have to multiply by 1.25. So I take the nominal, same as before, but now I'm multiplying with 1.25 instead of 1.15. And I get 25 amps. And that's what I set the dial on the OL to. Okay. This is just for the thermal overload, the service factor, okay, or the coefficient of the motor, which I showed you before was on the nameplate. Okay, I don't know if you want to take a screenshot of this. I'm going to go back to the previous page, and I'm going to show you where it is. Okay, did everyone take a shot if you wanted to? Okay.
Yep.
So the first thing I'm going to change is that that's page 8, not 7. So we said the service factor here was 1. If it's 1, what do we do? We're going to take the nominal.
1.15. 1.15.
Right. So nominal times 1.15, which means that I'm going to take the 58 and I'm going to multiply by 1.15. So if I do the math, if you figure it out before me, let me know.
66.7.
66.7. 66.7 amps. Sardi, what do we do with the 66.7 amps?
I think he went to the bathroom.
Huh?
There's in the chat.
Excuse me.
You set the OL, the dial on the OL. Yes, Mohsen.
It means when the motor is set this number, it trips after 66.7.
That is more complicated than a yes, no question. An OL is not like a fuse or a breaker. An OL is made for motors, and it's made to tolerate going over the set point by a certain amount of time. Okay, we're going to look at a chart. Tomorrow, we're going to look at a chart to see when it trips. Okay?
Yeah.
Okay. So it's a bit more complicated than that.
Okay.
So this is for the OL setting.
Yeah. Okay. I got it.
Okay. So it's not like a fuse though. Okay. Are we good with these 3 new things? Obviously, you're going to have to practice them. Okay. It's new. The rest of it is pretty much the same. But